Welcome to this lecture on the 15-minute city. My name is Dr. George Liu, and today we're going to talk about the 15-minute city in relation to accessibility and other concepts that we've covered in this course so far. First, we're going to cover the important topic of the 15-minute city. Number two, we're going to do some examples today about the 15-minute city, some real-life case studies. And then number three, we're going to talk about some ways that you can measure the 15-minute city. Last week, we went over isochrones, which are isolated, chron for time, isolated lines of times where you can travel, so the maximum distance that you can travel in a set amount of time. But as some of you remarked last week, the concept was a bit empty, right? Because we talked about last week that how far you can travel is actually not the most important point. Speed is not the most important metric. What I would argue is the most important metric is the amount of destinations that you can access, right? So if you can travel for 30 minutes on a highway and there's no pharmacy around on that stretch of highway, then going far doesn't get you anywhere. Think Alaska, think Siberia, think north of Norway, and these places where you could be in the middle of nowhere, you have very fast, congestion-free car travel, but you have no destinations to go to, right? You'll be back in the middle of the woods. So the thesis here is if you are living everyday life, what matters? If you're buying a house, if you're looking for ways to get around the city, what matters to you is accessibility and not speed. This brings us back to this diagram, right? You've seen this enough times. You probably see this almost every lecture that's being given, which is a great hint that maybe, perhaps, it's going to be on the exam, right? So we're going to do an exercise here, and this requires some audience participation. And this is, again, a very good potential exam question, right? So my question to you is, what's missing? Do we have a contender for what's missing right here? Land use, transport supply, long-term mobility, decision-making. If this popped up on the exam, could you be like, boom, 15 seconds, you should get this, 1 point. Yes?
So on the right-hand side is accessibility.
Uh-huh. And on the left-hand side? Left-hand side? Short-term mobility decisions. So short-term mobility decisions, we're looking for things that can change quickly, right? Accessibility is a measure of how many different types of destinations you can access, and those usually take a bit longer. So we're thinking like if you convert a pharmacy into a restaurant, a change of land use, those take relatively longer. But on the short term, what do we have here? Accessibility, and the short-term equivalent is activities, right? And these activities don't need to be linked to a building function. For example, you've heard of the salsa nights at Pinacotheken, right? So that's a museum, but a public space can be repurposed very easily and very quickly to different activities. Okay, so that's why activities are in the short-term category, and then accessibility are in the long-term category. What I would like you to come up with is really a model in your head where you can reason this out, right? So you could, for example, choose to remember 1, 2, 3, 4, what's the missing blanks, and just use brute force and memorize it based on where it is. But if you're able to reason and derive the different points, like what is long-term mobility decision, what is short-term mobility decision, you can not only answer this question, but also a myriad of possible questions that come your way, right? So for example, a variation on fill in the blank would be name 2 examples of short-term mobility decisions and what their impact is on this transport dynamics, right? Great question. You would have to know this, and then you would have to elaborate with some examples and some knowledge of how the arrows work. and what impacts what. Okay? So first step, memorize this for sure, but also understand how to derive this diagram. Okay, so today we're going to talk about mostly the activities and the accessibility part. Accessibility being the longer term counterpart to activities. And then this is related to transport supply and also land use. Right? Transport supply being what is available to get you to where you need to be. We can think one big variable would probably be public transport, right? If you're next to a public transport station, if you're in an urban setting, that is a very important component of accessibility. There are other components like how good the sidewalks are, if you have bike lanes, if there's a highway close to you, for example. But public transport, I'd say, would be one of the main variables. And you can see this in what? Housing prices, right? Housing prices, if you live close to a U-Bahn station, you're probably paying more for rent. That's an indication that people value transport supply. Right? Okay, so how does this relate to accessibility? Let's go over some definitions here, okay? So first definition, potential opportunities. And when we do the flowers of proximity exercise, this is an important concept. For example, you're young, you're fit, I hope you're healthy, right? Maybe hospitals and pharmacies aren't that important to you now. It could be very important to another population group, right? So when you fill out your flowers of proximity exercise, the potential for access to a hospital, you may not value it, but the population as a whole, like let's say that neighborhood, there's probably a huge demand, a huge value placed on that specific service. Conversely, university, proximity to the TUM, proximity to LMU, probably a huge factor in the younger population, right? If you're here to study, very important for you, maybe not so important for other people. Maybe there's too much partying going on at night if you live close to the university, right? So it could be a negative. But the potential, that's the important part. And that's what we want to measure. The second one is the ease of an activity, of an individual to pursue activity of a desired type, desired location, desired mode, desired time, right? So I'm going to use public transport as an interesting example here as well. Most modes, walking, cycling, driving a car, you don't rely on a schedule. So if your activities take place at 1 a.m. in the morning, but the train does not run until 1 a.m. in the morning, and it's far enough that you can't walk or bike, and you're too drunk to drive, then that activity, in essence, doesn't exist to you because there's no way you could access it, right? So again, we have some key points. Location, type, location, desired mode, desired time. The extent to which land use and transport systems enable groups of people to reach activities or destinations by means of a combination of transport modes. And this was covered in the 4 factors in the lecture last week, right, where there was a reading on this. So that's also an important factor. Okay, dimensions of accessibility. We have the accessibility of location, and then within this accessibility factor, you can break it down into 2 components. 2 components being transport and land use. The component that moves and the component that is stationary. Right? And then fundamentally, land use, we're looking at density, as perhaps density and use as major components, and then transport in terms of speed. But speed in relation to what? Speed in relation to how quickly you can access the land use component, right? So if it's a very low density environment, even if you have faster transport speeds, then maybe you still end up with less locations, less accessibility. What else is here? Location, characteristics of demand, characteristics of opportunities. Freight travel. So very different demands between people travel and freight travel, right? So the logistics of your Amazon package and how it gets from probably somewhere in China to your front door, and that whole chain of events, like shipping, ports, freight trains, getting onto a truck, is very different from the set of facilities that you as a human would want to use in a city. For example, a bar, quite useless if you're an Amazon package, right? Or restaurants and such, but for humans, highly desirable. So mostly we'll cover the human component in this class, but do keep in mind that freight really has its own logistical demands. We'll mostly leave that aside for the purposes of this class. But Amazon is a big part of how we get our stuff. Timetables, so access to activities, and then we have the individual component as well, right? Which is the characteristics of the people, kind of like what I said before. Your age probably is a big determinant of what you would like access to. And let's go to some principles of the 15-minute city. Okay. So we're going to go through some ways of characterizing the 15-minute city based on the works of some quite prominent academics. Okay, and it's, like you've seen, it's a rather complicated system. There are many components that define a 15-minute city, right? And it's a valid question to ask, what is a 15-minute city? Do you mean by foot, by bike, by public transport? What if you could drive somewhere within 15 minutes? Right? And I think for the purposes of this class, we're thinking more 15-minute city in the context of a sustainable mobility system. Right? So mostly we're going to try and set driving aside and focus on walking, biking, public transport. More on the how do we build a good urban 15-minute city, but there are also 15-minute cities out in the suburbs that are only applicable if you drive a car. Right? For example, if you live in a cul-de-sac in Arizona somewhere, you're probably not walking anywhere, not biking anywhere in a 15-minute city, and you are therefore car dependent. So one example. An urban setup where locals, this word locals, are able to access all their basic essentials at distances that would not take them more than 15 minutes by foot or bicycle. What did we find out about cycling when we did the isochrone exercise? That was rather surprising. You remember? Yes.
It was often comparable to the distance we can reach in cycling, or often comparable to the distance we can reach by public transport.
Yes, oftentimes the distance by cycling is comparable or even exceeds the distance accessible by public transport. And remember, cycling is an individual component. So if you show up to your bus stop, you can think there's a bus stop in front of the Lidl, right, at this university, and that bus on peak hours runs every 5 minutes and every 10 minutes off peak. So imagine you are there on a Sunday evening, you get to the bus stop, and the next bus is 9 minutes because you were running and you almost caught the bus, but you just missed it. So the next bus is a 9-minute, 30 seconds. In this case, right, if you're to think about a 30-minute city, you've already eaten up 9 minutes 30 by waiting, and the question is, where can you get to in 4 minutes and 30 seconds? So it's a really interesting thought experiment that public transit is a very unique mode compared to all other modes because you have the variability of waiting, right? So therefore, this focus on walking and cycling, it's in a way an easier approximation because it's more straightforward. Okay? And you've seen in the isochrones that we did last week, the pure distance and the reach of cycling, because it is about 3 times faster than walking. If we approximate a circle, if I have my math right, it's like 2 pi r, right? The area, no, pi r squared, the area of a circle. So basically, you were able to reach about three times the number of 3 times the distance for every doubling of speed. Okay. This leads us to some principles for planning for sustainable mobility: proximity, density, diversity, and then digitalization, which is a new kind of theme, right? If you can take a Zoom call in a coffee shop and you need the reliable internet, and that destination becomes, it becomes a bit like a portal, where it's almost like meeting other people. So access to Wi-Fi, access to internet. If you've ridden a Deutsche Bahn, particularly challenging, right? When you're going through rural areas, you probably would not be able to maintain a video call through that journey, which has impacts on accessibility. It becomes a place where you can't reach people. Imagine if you had perfect internet on the train, you could do a lot more, right? You could really work, you could have video calls. So digitization is interesting. New thing that's coming up. And then we'll touch proximity, density, diversity when we do the flowers exercise, okay? When we do the flowers exercise, you'll also see the 6 different essential functions. You can imagine, of course, based on your individual characteristics and your own needs, what is essential, but for the aggregate, so this was a survey done amongst many people, we can basically categorize it into 6 functions, and 6 functions: living, work, education, healthcare, commerce, and entertainment. Is there anything that's essential to you that is not in one of these categories? Yes? Access to nature, that is a good one. Yes. Yeah. Where would that fit? Okay, well, we'll see in the flowers. Maybe it fits somewhere, but maybe that could be its own category. Greenery, right? Yes? Transportation system. Yes, of course, we talked about transit stops are important, right? I think that more belongs into the transportation side. So I think this is mostly on the land use side when we talk about functions. Okay? I should clarify. So this is on the land use side. We assume that the 15 minutes is by foot or by bicycle. And then, of course, if you have a fast transportation stop, then you can reach way more, right? But by foot and bicycle, less relevant in this case, but that's a good answer. Yes?
I'm thinking about, for example, someone who is far from his family, and he'd like to have a high-speed rail connection next to his house in 15 minutes by foot.
So in some proximity to high-speed intercity transport, it could be rail, it could be airports, right? And we're quite lucky to live in Munich, in a big city. One of the attractions is lots of rail access and fairly good access by direct flights to other places. I think not in the 15-minute neighborhood concept, but that is a key factor that I personally would also think about. Yeah, so think about these things. 6 essential functions on the land use side, and then the transport side, we're going to have a whole discussion about that later on in the class as well. Chrono-urbanism. Time is a central factor in urban planning. Less time spent in traffic equals better quality of life. What is the assumption behind this? Of life. It's missing quality of life. chronotophy, change in the use of space as a function of time, and then topophilia, emotional connection of residents to their environment. Okay. So let's go through these one by one. Time spent as in a factor of urban planning, we're going to assume that we're talking about cycling and walking, but it could be driving as well. So having close, dense, well-connected neighborhoods, and recognizing that land use and activities are not constant over time. So what happens to a city is functions generally change as time moves. 200 years ago, about 200 years ago, restaurants were not really a thing, right? Like eating out, dining out, being served food, it was much less of a thing than it is now. So the restaurant, hotels started as a way to provide travelers some comfort on the road, right? But in terms of an urban environment, we can even venture to say that restaurants, in the grand scheme of time, are a relatively new phenomenon, right? And our cities had to adapt to this use. Grocery stores, we used to have small general stores, but this phenomenon of self-checkout, these larger supermarket where you would serve yourself, this didn't exist 200 years ago, but our cities did, right? So part of what makes cities resilient over time is building to accommodate different uses as we go through time. Which also means that the function required in the 15-minute city changes over time. Having a cafe with Wi-Fi, I'd say that's very high up on my list of things I would want in my neighborhood. 20 years ago, did that particular thing even register? Not so much, right? So having resilient 15-minute neighborhoods requires adaptation through time. And then this idea borrowed from urban design, your connection to your neighborhood. Part of the reasons that the mass production of housing is, it led to a more dominant, automobile-dominant society, but it also led to environments that were very bland, right? If you see these new mass built-out neighborhoods, they lack character, perhaps. Walking isn't as pleasant, and you lose this connection with the neighborhood. So that's something that is difficult to measure, but it's there. And this is also the thing that attracts tourists, right? Tourists like to be in nice neighborhoods. And if you could afford it as a student, you would also like to live in a nice neighborhood, right? All else being equal. We did some work that was funded by, I think this is Driving Urban Transitions or EIT Urban Mobility, one of the two projects. We have 2 reports that's on the internet. Feel free to take a look this week. But we try to expand these ideas to 8 principles. Okay? And these are explained in the optional reading. And I think this covers, like if you're a beginning urban planner, this covers a lot of what you should think about when trying to design a 15-minute accessible neighborhood. Okay. So we are going into more data-based metrics now. So we're going to take some real-life examples. This is from a study, a panel in the Netherlands that looked at distances between the different modes. Okay. Sorry, it's a German study. Yeah. So you got by foot, in dark blue by a bicycle, orange by car, and then car passenger, and then taxi, and so forth. Okay. And it shows, intuitively, you would know this, right? That closer distances mean more walking and cycling. Longer distances you tend to rely on the car and public transport, high-speed rail. So smaller neighborhoods, more closer neighborhoods, more use of walking and cycling. Less energy consumption, great for the environment, and so forth. Okay. Another way to illustrate mobility and proximity, so land use and transport. Two slightly different words for that, but the idea is like, do you have accessibility by proximity, where you bring the land use closer so you can access more destinations in a smaller amount of distance? Or mobility, do you travel faster in order to access destinations that are more dispersed? So two planning philosophies: bring destinations closer or travel faster to get to them. We can also think about some prerequisites for what it would take for you to go on a walking trip or a cycling trip as well. Okay, so accessibility is a prerequisite. So because you saw the distances, people aren't really willing to walk more than 2-3 kilometers or bike for more than 5 kilometers in general. But it's not a guarantee. So you could imagine you build a neighborhood where destinations are quite accessible by distance on foot, yet people choose to drive anyways. Maybe this neighborhood that you're building, lacks some of the higher order aspects. So for example, if you have a nice urban environment, much like the environment outside this university, right? Lots of people, good sidewalks, it's lively, you feel safe. Accessibility, safety, comfort are key factors. You're more willing to walk places. And places that you walk to feel shorter and more reasonable to you psychologically, right? You want to walk where other people's walk. You don't want to go where other people don't walk. And also, this idea of greenery comes up, right? You could have these stimulus coming from urban services, amenities. If it rains, it's nice to know you can like hide under an awning, right? And these small things, but also greenery. So if there's a park nearby, you could walk for recreational purposes. Let's take some examples from all around the world. So we did some studies through time, and it's only quite recently that the idea of the 15-minute city started to become popular. And we tried to map out like where do these policy documents, et cetera, self-proclaim themselves to be 15-minute cities. And you can see this is 2022. And here we are, 2024 last year. And then I suspect way more this year as well. 22, 24, and maybe the 15-minute city will take over the world, right? Which is one of the projects I'm working on. It's called Unlock 15. It's funded by the European Union. And we're looking for ways to how to scale up and expand this idea of the 15-minute city, how to apply it to more locations. We also see different concepts, right? So 15 is a relatively arbitrary number. It could be 10, it could be 20, and we're seeing cities play with this idea. And you also played with this idea when you used the isochrones last week, right? So 15 might be reasonable walking, cycling for many people, or if you if you take transit, for example, to work, maybe 20 is a much more reasonable distance. And that could still give you many of the functions. Okay, remember this from the last lecture. Different measures of accessibility. So infrastructure, location, person, and utility based. Could be some math in here, right? So we have the function that was presented last week. But most importantly is for you to understand what the logic is behind these indicators. Okay? So why they are determinants of accessibility. The 15-minute city, today's lecture was focused on location-based, right? We did not talk about the building of new highways, did not talk about what a new transit stop would do to optimize the accessibility of a neighborhood. We talked about more location-based measures, right? And this exercise will also be more location-based. You assume you're going to go by walking, cycling, 15 minutes is your radius, and then that being equal and constant, what do you need inside that radius? Okay. But we left out the transport side. Separate lecture. The idea is to hold one constant, change the other. It's much easier for you to understand. But of course, in the real world, both are moving all the time. And that's what makes planning so complicated. Right? You get a new S-Bahn line, it gets built, it changes the accessibility of a neighborhood because more people can travel, you have more access, and then people move, right? Activities change, and then there's new housing development, so next year you have a whole different set of metrics that you're working with. But for lectures, it's easier to hold one constant, see what happens, hold the other constant, see what the other thing happens, and then out in the real world, you have to acknowledge the complexity of everything. But you can still apply the same principles. Okay? Skip, skip. Let's take a look at a few other examples. We can look at Edinburgh, and this is what we're also developing at the chair, is a tool for not measuring just travel time, but also if you, say, have 15 minutes, what is contained inside that travel time boundary. So to really measure accessibility, it's not just travel time, but also how many grocery stores are within this boundary, how many restaurants are within this isochrone, and then doing the exercise for each of the separate uses. And so for living, work, etc. As you can imagine, this is a very computationally intensive process, and it requires way more data. You need to know location-based metrics of where everything is. So, so far there has not been an easy way to release such a tool to the public, but we're working on doing this tool for a few cities. One of the cities that we started with is Utrecht. But for other cities, if you have the data and you're part of the city government, you're often able to use this data to create an internal map of accessibility. And this is what that map is. It's using the number of services within a neighborhood to approximate, how well served each neighborhood is. So you can imagine an infinite number of isochrones laid on top each dot, and then placing a gradient on it, and then seeing which isochrone origins have the most access. And then you create like a colored map like this. Good? Okay. Similar exercise. So you start to see hot spots, right? Where do you suspect the hot spots are for accessibility? So this one is parks. Who mentioned greenery? Right, so we can separate out each of these functions and then make a map for each. We make one for parks, we can make one for restaurants, we can make one for bars, we can make one for universities or schools, right? So, and it's really powerful for urban planners to be able to see data presented like this, because you can imagine there are places that are deserts which lack access to certain functions, and then through a visual way, it's easier to identify which neighborhoods are lacking, and then we can use land use policies to encourage more development of those specific functions, right? You can zone a place for residential. You can zone a place saying like, a grocery store must be here, a commercial use. You can make a park designated as green space. Lots of things you can do once you have the data. Okay, this gets us to the exercise portion. And the exercise portion is, what do you need in your personal 15-minute city? And this is a tool that we developed at our chair, really cutting-edge research. And we're trying to figure out what people would like in their neighborhood. This map shows what you have access to at each part of the city. But the question remains, what would you like access to? Okay? And this is what we're going to create. So we're going to create the ideal neighborhood. And with this information, it's powerful for urban planners, because once you're able to aggregate, people's idea for what they would like to access, then you can then use data on a map to see what's missing. And you're able to tailor the city better towards the residents that live there. So today's exercise is a bit of wishful thinking, but it's very important, because we, as citizens, as residents of a city, that's what the city is. It's for us to live, a place for us to live our lives. And if we can present this idea of utopia, or do a public consultation, for example, to be able to gather what people need in their neighborhood, then urban planners are able to better respond to the needs of people. You might argue that, we just do whatever the market wants, right? You might argue that this process could happen naturally. Why do we need planning if, say, there's a high demand for restaurants, people are willing to pay for restaurants, then naturally the economy will build more restaurants, right? Business owners come in, they want to make more money, more restaurants will happen naturally. There's an interesting phenomenon that I want to tell you about, and why this doesn't quite work, okay? And this also explains why services tend to cluster. So whereas the ideal scenario is for these services to be dispersed, right? So, you with me? So ideally, you want services to be evenly dispersed around a city, so the maximum number of people have access to each type of service. But in economics, and if you're really trying to profit maximize, it turns out that the best way to capture the most customers, let's imagine a fictitious world, right, is actually for two firms selling the same thing to be located directly next to each other. All right? I'm gonna illustrate this with a trick. So, we have our linear city, okay? And ideally, and imagine a linear population distribution. What you want, if you have two stores, is probably you want a quarter of the way for there to be a pharmacy, and then 3/4 of the way to be another pharmacy, right? And let's play with this fictional city. So, in this way, all the residents from here go to this store, and let's say it's a 5-minute walk. All the residents from here go to this store, and let's say that's a 5-minute walk. You with me so far? Interesting fictitious world. All right, So if you're a profit maximizing business, and I'm trying to explain to you why things like cluster, if you leave them to their own desires. If you're a profit maximizing business, you'll do something quite paradoxical. And what would you do if you're the owner of either one of these businesses in this linear, equally distributed population world? Yes?
Move directly next to the other one.
Right, you would want to creep this way, and therefore you get all these customers plus all the customers here who have no other choice, right? And then in response, this one would want to creep this way and get all these customers who are being captured by this business. And then in the equilibrium, what ends up happening is you have two stores right next to each other, right? And then you have this poor fellow, 90-year-old man, who's walking 10 minutes to the nearest pharmacy. It's a bit of fiction, but I'm just trying to show you that sometimes what the market wants is suboptimal. This, of course, doesn't exist in real life. The population is not equally distributed. It's not linear. Cities are 2D. But you can imagine, right, scenarios where this happened. And you can see clustering happening in the real world. So, for those who say leave it to the market, not quite. So what we tried to do, back to this idea of what is your ideal accessible neighborhood, is we tried to ask people, how you would like to travel to different destinations. Some of you, I imagine, might want to prefer to bike to work. Some of you might prefer to walk. Some of you might prefer to take public transport, according to different scenarios. For example, when I go to work, I would like to arrive probably not sweaty. I bike to work anyways, but if I could arrive not sweaty and go by public transport, and I could read, maybe do some lecture slides on my way here, maybe that mode of transport is preferred to, let's say, riding a bike. Right? And maybe on some days more than others, maybe on a nice day I prefer to ride a bike and such. Maybe if you're going to the hospital, there's a high inclination to do that trip via taxi or driving or ambulance because you're hurt, and that's where you're going to the hospital, right? So we also try to capture the different preferences, not only what you would like in your neighborhood, but also how long and by what mode your limit is. So we find, for example, that the limit for going to the grocery store is much lower than your limit for traveling to work. So you can have a 30-minute commute to work, and that's acceptable, but to walk 30 minutes to a grocery store, that's very much not acceptable, right, to get a tomato. So we're also trying to figure out that type of information. And much of the challenge in designing these surveys is figuring out what the shortest path is to gathering this data without people dropping out midway. So you can imagine on one end where we collect all the data, but half the people don't finish the survey, and on the other end we don't get exactly what we want, but the survey is shorter and more people complete it. It's a balancing act, and also how do we present this information visually and such. But I think we've come up with something quite cool, and that works, and that's quite user-friendly to build this flower. So far we've had over 262 respondents as of last month, and we're trying to get over 1,000. Of course, we have a lot more in Munich than other places around the world, so I think it'll be nice to get your data, and of course, your data will actually be put into this data set. So how many of you are here in class? This number will increase by exactly that much, and that will feed into potential future research that we can do at the chair. So it's good stuff. And of course, we keep we ask you if you're a student, so we have also a lot of students because we're able to do the survey with more students. and we categorize that as students, so don't worry, you're not throwing off the sample size. We adjust for it. We see what people, top destinations, what modes people like to travel by as well. So we can turn all this data into bar charts. You know, for example, supermarket is number 1, cafe is number 2 of things that people want in their neighborhood. So far down the list. We can do other types of comparisons, public transit versus car, for example. Plotted on different types of destinations. So do people prefer to drive or take public transit? And then we can do interesting things like this. Acceptable travel time, right? Like what we were talking about before. So how far to nature is acceptable, and then the different colors represent different modes of travel. And you can see the workplace and the supermarket very different from each other, right? And then the modes are also very different. People are willing to travel way further to work, and then much closer to home for supermarkets. So now it's your turn. What we'll do is we'll take 20 minutes for you to fill out the survey. And then when you're done, just find someone else who has also filled out the survey. And I'd like you to share your flowers with another peer when you're done. So as soon as you're done, you can also look elsewhere, like let's say maybe you can get up and go to another place in the room so you have more room to chat, and then just look for someone else who has also finished. All right, and then when you're done the chat, you're actually dismissed from this class. So if you want to go early after you finish the survey and do the chat, you're free to do so. It's been a good lecture. Thanks for moving close to the front. I hope you enjoyed that and there was some good information for you. The link is in, it's in Moodle. Yes, I posted there. So go to the Moodle survey, cookies, and so forth. Thank you very much for your attention.